Here is a very simple problem. We have a curve y equal to x square. Let's assume p x comma y be any point on this curve. The abscissa is increasing at the rate 1 unit per second. Abscissa means x coordinate. X coordinate is increasing, which means dx by dt is 1 unit per second increasing, so I am written positive. Then find the rate at which slope of the tangent. We remember slope of the tangent is nothing but dy by dx. So if I differentiate, I'll get the slope here. So y is x square. So dy by dx is 2x. So slope is 2x. But I need the rate at which the slope is changing. Rate of change of slope is dm by dt. So I need to differentiate this with respect to t. So dm by dt is 2 into dx by dt, which means rate of change of slope is 2 times the rate of change of abscissa. Rate of change of abscissa is 1, so I get 2 into 1. Hence, the rate of change of slope is 2 per second. Rate of change of slope is increasing and it's increasing 2 unit or 2 per second. Here we are talking about a vertical conical water tank which is laid upside down, and the water is poured into this conical tank at a fixed rate. So first thing, shape of the tank is inverted right circular cone of semi-vertical angle. Semi-vertical angle, this angle is tan inverse 1 by 2. Water is poured at a constant rate. So water is poured into it at a constant rate of 4 cubic feet per minute. The depth of the water is 8 feet. So at a particular time, the depth of the water is 8 feet. So let me take the depth of the water as x and the radius is r. Remember, when the water level is rising, x also varies, radius r also varies. Both of them are varying, and volume also. There are 3 variables involved here. One is the volume. Volume is 1 by 3 pi r square x is the formula for volume. When I take this, there are 3 variables involved, but we need to make it into one variable. That is, the right hand side should be made into one variable. Then only we can calculate it. So what I'm going to do is, I'm going to get a relationship between r and x by using this tan inverse 1 by 2. We know that tan theta is r by x. Opposite side is r and this side is x. So I can say tan theta is tan inverse of 1 by 2. So tan of tan inverse 1 by 2 is r by x. So 1 by 2 is r by x. So instead of r, I can write as r is x by 2. So I got a relationship between radius and the height. So I got 1 by 3 pi r square. Instead of r, I'm going to write x by 2. So x by 2 the whole square. X by 2 the whole square into x. So I'll get 4 pi divided by 12 x cube. 4 into 3, 12. X square into x gives you x cube. So this is a relationship between the volume and the height. Now I'll differentiate for getting the rate of change. So dv by dt is pi by 12 3x square into dx by dt. Now what you are left with only substitution. The water is flowing at the rate 4 cubic feet meters per second. So this is 4 cubic feet per minute. 4 into pi by 3 and 4, 12 will get cancelled. Now x stands for the height. We need to find the depth of the water at 8 feet. So into 8 square into dx by dt. So dx by dt is the rate at which x is varying. That means height of the water level is varying. So dx by dt is 4 into 4 divided by pi into 64. And x stands in feet, so feet per minute. So my final answer is 1 by 4 pi feet per minute is at which the rate of the water level is increasing. Rate at which water level is rising is 1 upon 4 pi feet per minute. I'm going to find area of a circular top the rate at which the area of the circular top is changing or increasing. This is a circular part of the surface. We'll denote this A by pi r square. A stands for the area, r is the radius at that time, at that particular time. Now r can be replaced by x by 2. So pi into x by 2 the whole square, because we know dx by dt. We have dx by dt we calculated in the previous problem, 1 upon 4 pi feet per minute. So we can use that. Now I will differentiate with respect to t. So pi by 4 into 2x dx by dt. So which I can write as pi by 2 x. X is nothing but height, that is 8 feet, and dx by dt is nothing but 1 by 4 pi. So that gives pi gets cancelled. So it becomes 1 square feet per minute. It will be the area of the surface is increasing at the rate 1 square feet per minute. Now we shall calculate the rate at which curved surface area is increasing. Curved surface area of a conical cylinder is C is equal to pi r L. L stands for the slant height. L stands for the slant height. So we can get a relation between L, x and r. That is L square is equal to x square plus r square. This is by Pythagoras theorem. R can be replaced by x by 2. That is x square plus x square by 4. That becomes 5x square by 4. So I can say L is root 5 by 2x. So my surface area now became pi r is x by 2, and L is root 5 by 2x. So C is pi root 5 upon 4 x square. Differentiating with respect to t, I want to find the rate at which surface area is increasing. So dc by dt is pi root 5 by 4 into 2x dx by dt. That is equal to pi root 5 by 4, 2 into x is 8, dx by dt is 1 upon 4 pi square feet per minute. So further calculation, 16 get cancelled, pi gets cancelled. So root 5 square feet per minute becomes my final answer. So the rate at which surface area is increasing is root 5 square feet per minute. Slightly different problem. The length of a rectangle x is decreasing. Length is decreasing at the rate of 3 centimeters per second. And the width y is increasing. So here one side is decreasing, other side is increasing at the rate of 2 centimeters per second. Find the rate at which area is changing when x is 10 centimeter and y is 6 centimeter. So it's a rectangle. So what are the varying length and width? A. So the relation between the three is A is equal to xy. Length is decreasing. So dx by dt is decreasing, minus 3 centimeters per second. Dy by dt, width is increasing, 2 centimeters per second. Then x value 10, y value 6. What to find? dA by dt. So I am going to differentiate this with respect to t. Remember, x and y are both variables, so product rule need to be applied. So dA by dt is x into derivative of y plus y into derivative of x. So this is important over here. When you find that rate, both has to be differentiated. So x value is 10, dy by dt is 2, y value is 6, and dx by dt is minus 3. So which gives me 20 minus 18, that is 2. What was the unit? Centimeter. So centimeter square per second. So my conclusion is area is increasing at 2 centimeters square per second. Here the word is increasing because you have taken decrease as negative, so positive will be taken, will automatically become increasing. Let's imagine a lamp post of 15 feet high. Here is a lamp post of 15 feet high. A person, let's say 5 feet tall, is walking towards a lamppost. Is walking towards a lamppost. The shadow from the light falls, let's say, at this point. So A is the tip of the shadow, B is the lamppost, BC is the lamppost. Let's say MN is the man. So we are given the lamppost is 15 feet high, height of the man is 5. The variables are, he is walking, so this distance is x, which is varying. So naturally, according to the position, the shadow's length also will change. So let's denote this by y. So the variables here are x and y. So the importance here is how we will find the relation between x and y. We shall use the similarity of triangle. Triangle ABC and triangle AMN are similar triangle. So I can say that BC upon CA should be equal to MN upon NA. This will be used to find the relation between x and y. Now BC is 15, CA is x plus y, MN is 5, NA is y. So you can say this 5 and this gets cancelled, 3y is equal to x plus y. So 2y equal to x. So the relation between x and y is 2y should be equal to x. Now if I differentiate this with respect to t, remember I know the rate at which man is walking, so I need the rate at which y is changing. So I'll write 2 dy by dt equal to dx by dt. What is known to me is dx by dt. So dx by dt is given to be 2.5 feet. The rate at which man is walking is 2.5 feet per second. So I can say dy by dt is half of dx by dt. So half of 2.5, let me write as 2.5. That is equal to 1.25 feet per second. The shadow is shortening at, so my first answer, the shadow is shortening at 1.25 feet per second. And the tip of the shadow, what is the tip of the shadow? The point A is moving. So the tip of the shadow means the rate at which CA is changing. That means the rate at which x plus y is changing, which is dx by dt plus dy by dt. So dx by dt is 2.5 and dy by dt is 1.25. That means 3.75 feet per second will be the answer to the question how the tip of the shadow, rate at which tip of the shadow is moving. The rate at which tip of the shadow is moving will be 3.25 feet per second, and rate at which the shadow is shortening will be 1.25 feet per second.